If your chemistry teacher did not teach you how to get full marks in 6 markers, don't worry, I'm here. Now guys, who am I? I am not a teacher, not an examiner, but I did A-levels once. So this is not secret insider information, okay? This is just what worked for me to get full marks in my exams. If you haven't seen this video already, go watch it. It's gonna help you with that skill issue you have with A-level chemistry. So as you can see here, I got full marks in my 6 markers and 7 markers, all of them in the 2025 exams. So I feel like I can say a little bit about 6 markers. Now, in my opinion, there are 5 main steps in order to get full marks. So the first step is to identify the type of question. The second step is to question the question. The third step, I don't know why I'm shouting here. It says less is more. The fourth step, rinse and repeat. And the fifth step is talk about NMR, mass spec, whatever. That's just a different ball game, right? So let's just move on to this first step, okay? Identify the type of question. In my opinion, there are 3 types of 6 markers, okay? We've got your calculation 6 marker, explanation, and prediction, right? Now, what's the difference between these 3, right? So a calculation type of question is literally a calculation. You're literally doing maths. Maybe there's a brief explanation, which is like 2-3 words, but that's it. An explanation kind of question is a test of theoretical knowledge. So seeing if you can talk about practicals, properties of compounds, is basically just a whole bunch of writing. And a prediction kind of question, it kind of sounds similar to an explanation, but think of it more as the child of calculation and explanation. So they're mainly found in paper 2 and paper 3, and they're trying to see if you know what organic compound comes next, or whether or not you're able to use your knowledge in order to find a compound or find an element within that question, right? So I've got a few examples over here. So you can see here this rate equation question. Find the rate equation, rate constant, orders, and explain your reasoning. The explanation, again, it's not a PE paragraph. It's like 2 sentences. This question over here, show all your working. They don't want to hear you speak. They just want to see you calculate and do maths. Now, onto the theoretical questions. Here is a perfect example. Explain the melting points. They just want you to explain and look at all those lines, right? And over here, it says describe, but the reason why I would classify it as an explanation question is because you're just talking. You're just going through the ways to make a standard solution. These are the prediction kind of questions that they give off the same vibe, in my opinion. Like here, you're using your theoretical knowledge to see whether or not you can create and predict the right intermediate. Now, same over here. It doesn't tell us to explain, and it says describe, but the description here is very limited. And again, over here as well, they're trying to see whether or not you're able to create these compounds using your knowledge. And that's the first step done. Okay, let's quickly move on to the second step. The second step is question the question. Now, what do I mean by this? Okay, ignore what I've written over here. This is actually, what I'm trying to say is that every topic will have its own calculation, prediction, and explanation type question, okay? The style will remain consistent throughout. So let's say you have a calculation question for reaction rates, right? Yeah, so as you can see here, I've got 3 questions for reaction rates. They're more or less the same. You can see here in this first question over here, determine orders, rate equation, rate constant, and I've got a table. The second question, I've also got a table. They're asking me to determine the rate constant and a 2-step mechanism. So these 2 questions are essentially the same, except the second one is asking us for a 2-step mechanism. We've got this third one over here, and you may be thinking, like, this is low-key a bit different, like I'm seeing a graph. No, you've got your table again, and I believe that most of your marks will probably come from the table because you're calculating stuff. And over here, you've got concentration time, rates, concentration graphs, and this is what you're going to be using in order to determine orders. So you are working out the same 3 pieces of information each time. So just because they are consistent, it does not mean you fall for the trap of assumptions. What do I mean by this? It does not mean you always determine the orders, rate equation, rate constant for reaction rates. You need to read the question and see what you have been provided. So sometimes they might already provide you with the rate equation or rate constant, and they might just want you to work out the initial rate, for example. So get used to the fact that questions are similar but not the same. The third step is less is more. What do I mean by this? I'm talking about the amount you write. Why is the amount you write important? So that we don't go off topic. Let me just give you an example, okay? We have this beautiful question here. Explain melting points in terms of bonding and structure. Does it say ionic radius? No. Does it say electrical conductivity? No. Does it tell us to talk about atomic radius? No. Okay guys, so then why am I seeing some people talk about electrical conductivity? Again, why am I seeing you guys talk about things that the question doesn't want you to talk about? The stuff that you're saying may be right, you might be saying the right things, but is it what the question is looking for? No. So then don't talk about it. How do we make sure that we don't go off topic? Well, there are two main things that you can do to make sure you don't go off topic, and you'll be able to see this in your answer. So the first thing is to use the information in the question in appropriate proportions. So let's just use this question here as an example. So you can see here, we've got the question and we have 4 pieces of information, right? That doesn't mean I'm going to zoom in on, let's say, silicon and talk about its amazing giant covalent structure. No, I'm going to talk about each thing with due respect. I'm going to talk about each thing maybe twice. I'm not going to focus on one thing. I'm going to speak about everything, each piece of information that I have, equally according to how many marks the question is. Let's say if I have 3 pieces of information and the question is 6 marks, that means I'm going to speak about each thing twice to ensure that I've covered all my bases, right? So that's the first thing to ensure that you don't go off topic. The second thing is to use bullet points and dashes. Now guys, we're not using full sentences here in A-level chemistry because that could lead you to go off topic and just waffle, right? So bullet points just makes it a lot clearer for you and the examiner, and dashes just helps you to join pieces of information up without creating a full sentence and risking you going off topic again. Now what do these two things give you? It gives you this. I'm sorry guys, it will give you roughly 6 or 7 bullet points. So if you have more than this, you might have written a bit too much, and so you should look over again and cross out anything that seems a bit irrelevant. If you have less than this, then just read over the question again and see if you've missed out any pieces of information. Okay, we're on to the 4th step right now. The 4th step is rinse and repeat. So we already know that questions have a consistent style throughout all the years, right? So what does this mean, guys? It means that we need a set structure, okay? If the questions are more or less the same each year, that means we can more or less use the same structure and get full marks each time. Now, how do we do this? I don't want to sound like everyone else, but just keep on doing past papers and just psychoanalyze them. Psychoanalyze what? The mark scheme when we're doing these papers. And you'll find 2 main things. Number 1, each rewardable line of reasoning is going to be in the same order in the mark scheme. So anything that gives you a mark will be in the mark scheme, but it's also going to be in the same order each time for each type of question. And the second thing is that you'll see roughly the same 5 or 6 things that are worth giving marks. But why is this even relevant? This means that you're able to present your answer in the same order of that of the mark scheme using the keywords that are in bold or underlined in the mark scheme, right? Let me just give you an example. Let's say we have this question, which is out of 5 marks, but the same principle applies. It's asking us to determine the orders, rate equation, and rate constant. So let's say we do exactly that, okay? First order, second order, I've given the rate constant, and I've gotten my units. So hypothetically speaking, I should get full marks because I have given everything. Let's just scroll down, okay? Let's just scroll down. But you can see here, I only get 3 out of 5. Why? Because I forgot this part. I didn't explain. Explanation is a bit difficult. So look, the explanation is here. I can't just say it's second order, right? I have to say it also doubles and the rate quadruples, and it's the same thing here. So even though technically I've got the answer right, I'm not going to get full marks. And what if I were to get something wrong? What if I got my rate constant wrong, for example? That means I'll go down to 2 out of 5, and I don't even have my workings, so they can't even use that to back me and give me a mark. So using this mark scheme, seeing that, okay, they've looked at the orders first, then the rate equation, then the value of K and the units of K, and over here in bold, and so I know that I need to include that. Let's answer the next question using the same structure as seen in this mark scheme. So our next question here is this one. So prove the rate equation, calculate rate constant, and give to 2 significant figures. So over here, I've got when the concentration of the reactant is X, initial rate is X. Why? Because look at this previous question. When this is this. So I've literally just copy and pasted that, but I've just changed what the reactant is. And same thing here. We've got our rate constant. We've got our workings out for that over here. And I've made sure I've implemented that over here too. But why do I not have the rate equation because they've given it to us already. So I don't need to actually present that because I'm not going to get no marks for it. So if I were to scroll down to the mark scheme, let's see. Using my structure, would I get each mark? When hydrogen peroxide blanks, initial rate blanks, yeah, okay. So I would get the mark. When I minus does this, initial rate this, so therefore I minus this, yeah, I'll get that too. When H plus this, yeah, see, so I've already secured 3 marks just by doing that, right? If I go down here, units, I've given my units, mark, what else is here? Rate constant as well. And you can see here, rate constant, I've given formula, okay, cool, they want to see that formula. I've given the answer. So I've gotten full marks just by using that set structure. So by having a set structure that follows the mark scheme, it means that you're guaranteed all the marks in almost every question given in the same style. Because you can see here that those 2 questions were more or less of the same style. Now, the final step is talking about mass spec. Yeah, so with mass spec and NMR and whatever it is, it's just long. It really is just long, and the mark scheme is just so specific. But what's interesting about the mark scheme is that it usually says to check the graphs for any annotations. So it low-key lets you get away with writing less. So let me just give you an example. Let's look at this carbon one, for example, right? Usually down here you'd have to write, oh, the largest peak on the right hand side is this, therefore the MZ is this and it's 91. You don't have to do all that if all you do is label this as MZ and say 91. So you do get away with writing less and you still get the marks. And it also lets you work it out a lot easier. It's basically your rough draft. So annotate the graph and spectra, then jot down the essential information on the lines. Think of this as your canvas, right? But this is the explanation for your art piece. And the best way in which you should present your information for H1 in particular is this. So you have your shift, and then you say what environment it is, what split, peak, adjacent protons, and deductions. Sometimes they already give you that kind of information, as you can see. In this case, just draw an arrow and state what this is. For example, you can see triplet peak here. Just write it down again, triplet peak. And basically, that's it. That's how you're going to get full marks in your exams.